Welcome to the CircuitPython Show. I'm your host, Paul Cutler. This episode, I welcome Michael T-Rex Kadie. He is an engineer builder, an openly autistic adult, and the founder of SSI Racing. He earned a BS and MS in computer science from the University of Wyoming with a systems and AI thesis dedicated to building a custom hardware-software augmentative communication device for two non-speaking children. That project set the trajectory. He spent the next 3 decades shipping embedded firmware, real-time systems, and production software across telephony, manufacturing, and wireless, including a stretch as staff engineer at Qualcomm, and along the way designed the battery management system used in the FDA-certified electric wheelchair, and a world record-setting electric car that was on the main floor of the Detroit Auto Show for some reason. Today, through TSSFAA.com, which stands for T-Rex, Successful Slightly Famous Autistic Adult, he releases open-source assistive devices built on CircuitPython. The main project is the T-Rex Talk family, tactile AAC boards built around the Adafruit microcontrollers featuring the RP2040, RP2350, and ESP32, with a new T-Rex Talk 3.0 generation moving to the RP2350-based Adafruit FruitJam and similar cores. Michael, welcome to the show.
Thank you. Good to be here.
How did you first get started with computers and electronics?
I started with a Radio Shack 101 electronics kit and moved after that to a TRS-80 Model 1 computer, so I know how to program computers the hard way.
Going all the way back to the TRS Model 1, is there a favorite computer you've had in the last 40 years over that time?
Amigas were definitely my favorite computers. They just did amazing things.
How did you get started building communication devices in the 90s?
I was on a road trip with a friend's family, and there were 3 family members in wheelchairs, one of which I was assuming that because he wasn't able to communicate, that he wasn't smart. And as soon as I realized I was having this awful thought, I decided to do something about it. So for the rest of the road trip, we talked about what he can and can't do, and I was taking notes and inspired 6 to 9 months later, I had sent him off a working full language system, which he then used to join a normalized 7th grade classroom. So amazing success.
Well, that's pretty cool. Did that serve as the inspiration to the T-Rex Talk 3.0?
A little bit, yeah. After I finished college, the iPhones were coming out, and there was some communication software on the iPhone, and I kind of figured that, hey, it's easier. People are getting everything they need now. And was busy, kind of hyper-focused on work and all of that other stuff. And as I'm starting to think about what I want to do with the rest of my life, I was like, that was the best thing I've ever done. I want to do that again. And it's like, oh, there's still holes. They're not as many as there used to be, but for what Michael was the name of the person I built the first one, people with no fine motor control skills, it's really hard to find good devices. So it's like, oh, I already know how to do that. On vacation, I met an adorable girl named Moana, who also can't communicate, and I was working on just a basic needs board for her. I was like, yeah, I can do this. And I got that sent to her within about 6 months with a lot of revisions internally and she got a much nicer one than the one that I have laying around. She's still using it after a year. It's not fully filling the communication needs, but it does seem to get her more cause and effect reactions. So wonderful. And I'm going to try and work with them again and try to build a device to bring her into more interactive communications, because that's her favorite toy. We can't do anything with that. That has to stay as it is.
That's really neat.
Thank you.
Let's chat more about the T-Rex Talk 3.0. What is it and whom is it for?
Okay, so I took the Moana device around, and a friend of a friend had a stroke, and he's a former military person, and one of the favorite things he had in his life was swearing. So he made the grumpy old man device, which is similar, but because it's newer, all of the things I learned went into the grumpy old man device. That was the version 2, and there was a bunch of other stuff trying to build it into an open source ecosystem so that other people can come on. And then I went to open source maker fairs and talked to a lot of people, and I found out about selective mutism, which is more preferred to be called involuntary nonverbal people. And for that, I was thinking, a little credit card size device, kind of something that size that they could wear, have in a pocket. And when they are unable to communicate, it can just have a smash button that says whatever their instructions are when they are unable to speak. And then it also, I love rotary encoders. They're so fast. As a full rotary encoder menuing system to be able to, in theory, also do full language communication or, quick needs access. And these were now 3 separate software bases. I was trying to figure out what wanted to be the kind of ultimate compute board, which I decided was definitely the 2350 Pico 2 and the CircuitPython 10 on their Fruit Jam device with the automatic SD card loading up when you plug it in was like, because it's a pain in the tush to take the SD cards out and load them up, because when we're talking about, especially my goal is to eventually have an SD card with 12 languages, kind of 50,000 words just to ship out. You don't want to have to do that through the CircuitPython going back and forth to the SD card. And you don't want to have to pull it out, stick it in the computer and put it back. So it's like, that kind of made me decide what the core is. Unfortunately, the base device draws too much power without removing parts. And I asked, and even for a reasonable order size of like 100, they won't do any special runs. So, and that's fine. I already had 3 other versions of RP2350 kind of circuits. So because they're open source and I'm open source, I'm taking their baseboard and integrating it into the next version of the device, getting rid of all of the stuff I don't need, which basically is just leaving me with the much nicer sound chip than I was using and the QSPI micro SD card, and then all of the pins Pico. And according to the calculations with my own power circuits, I have to add another chip to do some of the wake up stuff. I should be good for between 4 months and 2 years of idle time, just quick launch on a regular 18650 battery.
That's really impressive.
Thank you. And then part of the 3.0 was bringing all of these different disparage code bases together. And disparage AI or not, it was like, it made it really easy to say, okay, here are 3 different code bases. Let's bring them together using kind of the class architecture that I'm fond of, the long variable names that I'm fond of. And it's been wonderful. I would have never gotten the CYD version of the software working, which is an ESP32 based with built-in touchscreen without Claude, because it would have just been like, no, your documentation is bad. I have better things to do. Whereas I was like, oh, you go try doing that. I'm going to work on the main stuff. And when you need help, I have 2 computers, no waiting for me. I mean, one of the goals is that getting other people into the system to help build devices, especially for people that they know with unmet needs, having to send off for circuit boards, group buys or whatever, impedes it. And now we have the fruit jam. You plug it into a monitor, you plug in a keyboard, poof, you can run kind of nearly any version of the software, which is great for a developer. Now, with the CYD, there's a kit which comes with a speaker and a better sound without the sound problems that the typical one has. So you buy that kit for like under $20, a battery for 10, plastics, and now you've got a complete system, touchscreen, under $40. So you can use this with no need for special hardware. It's running the same source code with just changes in the configuration files, which are text files with lots of explanations and meaningful names. And so the 3.0 has really come forward. It does have submenus, which allows you to say, here are my food and drink tasks. Hit that, and then it's like you could go food and drink, fruit, apple. So we get you through just an enormous amount of possibilities in a very intuitive and quick fashion. And then it also has untested, what I call the infinite lists items. So any selection can be something that speaks and has lights and vibration, haptic feedback, and all of that. That's options on all of these. You go to a submenu, and it can now go to a list menu. List menu is text only. Lists are alphabetical, and it can be sentences and words. And this is what I did for Michael. So it allows you to select what I would call a human optimized fashion, so that there's an intuition for parsing through this, not just some binary tree, which our brains don't think of well, to get to say what you want. And then, because I've been really inspired and productive since vacation, I have it so that it now has a sub-program option. And the sub-programs are something which are for a group of autistic children, are going to be the first real bulk build that there's an annual charity run where they've bought 30 what they called stim bats, which are stimulation devices. Well, this one for them, it has tilt, it has a QR code reader, it has buttons, it vibrates, it's got a touch screen, it's got colors, it's got sounds all together. And I think it's going to come in with a bill of material under $100. And then to go with that, we're going to have a bunch of interactive learning games and, kind of stimulation response tailored to different needs or educational goals. Right now, I made a working training game where the device will speak a question to you and you select from the list of menus as to what the appropriate response is, and it times you and it keeps high scores, and in theory that should be engaging, and it will get more engaging before open source is my big public release of everything, except for this, obviously. And because I was in a mall waiting for my friend to get new glasses, and there was a T-Rex squeaky rubber chicken equivalent, I thought, oh, the sip and puff sensors are something that exists in the open source, but the ones I saw weren't great. And egotistically, I thought, I think I can do something better. And not egotistically, I went and researched all of the other papers, all of the other write-ups. And that was so good because they mentioned what their weaknesses were. So right now, I've definitely tested the sip and puff to select and rotate through my communication device, and it works. Intuitive, all of that. I tested a little bit with the orientation, which could be on the straw, it could be on a little headband or something. That's as far as I got on that, because where you put the sensor makes a world of difference in terms of how it's going to react, but it'll also work as a mouse. And in theory, it's also already working as an Xbox accessibility controller.
Oh, that's great.
Yeah, I mean, you just kind of, in software engineering in general, you kind of reach this kind of plateau where things are just coming together. And with CircuitPython, that plateau is really, really spinning out fast and easy. I mean, if I was doing this in C, C++, it was like, yeah, I would definitely have a good working system for Moana and probably be at the 2.0 device stage. But I wouldn't trust anyone else to work on the source code.
So would you say that's using CircuitPython sped up development for you?
Oh, by orders of magnitude. I mean, I started using Python at work, and that definitely was a huge win. And then it's like, oh, CircuitPython is close enough that I can cleverly just write kind of what's my processor, what's my OS, and have the same code work on a Windows machine, Raspberry Pi, or CircuitPython device. And only the graphics change. I just knock out crazy number of devices. I have a reading/night light that is running CircuitPython. It's also controllable over the CAN bus to be an indicator for automotive problems or solutions and a lot of other things. But mostly I've used it as a USB, smack it, and I've got a nice settable brightness, settable color light for traveling.
Oh, nice. Speaking of automotive, tell me how CircuitPython came to be retrofitted into an antique car owned by Jay Leno.
Okay, well, that's in progress. I used to do electric car conversions. As my main gig, I still am an electric vehicle engineer, but now I have a regular paycheck, and we were working with Jay Leno and his mechanics on a different project, and along came a barn find of a 1911 Detroit electric car that was not restorable. And he decided he wanted to retro mod it. So he brought us on board a while ago, and it kind of got a little momentum. And then those were early days, and kind of everyone was acquired or went out of business. A few years later, it came back, and they were like, okay, we're back on the car. We need some help. And we have these gauges that we have no way to drive and some indicators. And was like, okay, I'll take one of my utility boards, which used to run C, but it's been running CircuitPython for about the last 5 or 6 years. The ESP32 gives you the CAN bus really easy. Some other chips do as well. And it's like, so I've just put that together, started writing some code to take advantage of the CAN DBCs. So I put together a version of my hardware for him, and it's much nicer than it would have been before. So it's like, not only does it do what he needs it to do, but it's got a little OLED screen on it that displays whatever we want. I threw a rotary encoder in there so that we can run tests, run simulations, all of that. And then it all fits into an IP67 case. Whether or not, doesn't matter if the OLED or rotary encoders are in it or not, but for testing, that's just so easy to do. So they're very excited about that. They gave me all of the information. I'm supposed to get the gauges to start testing this week. And then in a few weeks, I'll go out and start integrating on their vehicle. In the meantime, I took a 4-channel audio mixer that also I made it to be an audio mixer, USB keyboard like device, but also to be able to read and stimulate the CAN bus, because I can, because I have all of these libraries that I built over the years. It's just like suck them in, just say, if CAN bus, do this. And so I'm going to be programming that. It has a big color screen to be able to emulate all of his systems so that we'll be able to do tests with nice displays as to what's happening and make sure that my device is properly calculating all of the calculations. And then eventually we can plug it into his car if there's any problems, see what's going on, and also be able to stimulate any missing input to get it going.
Well, that's pretty neat. Last question I ask each guest. You're starting a new project or prototype. Which microcontroller board do you reach for?
Well, if it needs CAN, I reach for an ESP32. If it doesn't need CAN, I reach for Pico 2, because the RP2350 just has stupid good horsepower.
Especially for the price.
Yeah. Throw the PS RAM in it so that I can do animation on the screens. And
Michael, thanks so much for coming on the show.
thanks for having me. Have a wonderful weekend.
Thank you for listening to the CircuitPython Show. To learn more about Michael and the T-Rex Talk assistive devices, visit tssfaa.com. For show notes and transcript, visit www.circuitpythonshow.com. Until next time, stay positive.